We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle Compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann Parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live-to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick-pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
I wanted to take a quick minute to talk about one of our sponsors that make this podcast possible, and that's Parker Sporlan and the Catch-All Filter Dryer. Do you know what can reduce system efficiencies and reliability within your refrigeration system? If you answered contamination, you are correct. Sporlan Catch-All Dryers have been around since 1947 and have been perfected over the years to capture water, acid, solids, debris, including sludges and varnishes. For best practices, change the Catch-All filter dryer if any of the following occurs. Initial system install, when a system is open for service or repair, when excessive pressure drop of 5 psi across the filter dryer, when the See-All sight glass indicates water is present, when doing a T1-1 acid test kit says there's acid present, during a compressor burnout cleanup, and following a successful burnout cleanup. To find out more information by downloading Bulletin 40-10 from Sporlan.com with all the Catch-All filter dryer information. Thanks, guys. Enjoy the episode.
Proper wrong?
Yeah, probably. I'm the world's best phonetic speller. Hello, everybody, and welcome to Advanced Refrigeration Podcast.
Yep.
You're here with your hosts, Brett Wetzel and Kevin Compass. Brett Wetzel's the world's best phonetic speller, if you guys didn't hear that.
I can't say anything because I am the worst speller ever. So, I mean...
Well, you know, I told someone, like, you know, remembering all this stuff sometimes it's kind of like, you know, your brain's a cup of water. You fill up with so much stuff, you start to lose some stuff. That's why I can't remember birthdays and anniversaries and when I'm actually supposed to be on vacation. Like, I don't know holidays at all. Like, I'll schedule a trip to be, you know, to go somewhere, and my wife's like, well, that's Labor Day. I'm like, okay. Does that mean I have off? She's like, yeah, that means you have off. All right, cool. So, how's your week like this week?
Off for you.
What's that?
Is it nothing?
No, what did you say?
I said every day is a day off for you.
Oh, shut up! I'm productive. I'm doing lots of stuff.
Oh, my week has just been, I don't know, irritating so far.
Anything crazy?
No, yesterday was a bit of a hassle. Everything from getting a speeding ticket from going 5 miles an hour over, which I am still salty about on a highway. Never in my life have I got a ticket 5 miles over on a highway.
Well, next time
Then I went and
next time what you got to tell them is just say, hey, I just came back from Texas, and theirs is 10 miles an hour over, so I don't understand what the heck this 5 mile an hour business is about.
Yeah, then I went to go help some guys with an E2 that lost its program, and I ended up bricking it.
Yeah, I saw
when
that.
I say brick, I mean like white screen, bad hard drive, completely screwed. I mean, the E2 was bad, but like I drove 3.5 hours to go do this and bricked it.
Have you ever tried just changing out the little hard drive that it has, the 256 or whatever it was, whatever's in there?
That flash drive. So I actually had one in my van.
And
no, that's not the hard drive. That's the bootloader.
Really?
So the hard drive is actually built into the controller. That is the actual the bootloader for the controller. That keeps the boot file on to start up everything online.
Because I thought I've taken that out and it actually transferred the program. I could be totally wrong, but
no, it'll transfer the bootloader program. Because I have one sitting in my truck that has a bad bootloader. Mm-hmm. Meaning that the memory card's bad. So now I have a good controller. Maybe.
Be for sale?
I don't know. I had to find it. No, I had to find it. It is buried all the way in my van, and I literally can't even open my back doors. So.
Hey, remember that?
All right,
remember
guys.
that conversation? Hold on. I just want to remember this real quick because I remember the conversation. My van never gets like that. Never, ever. No, it's always clean. Always clean out.
It is stacked front to back with pack outs and job materials. So, when you do a job 100% by yourself and you have all the material and tools in your van. So,
but your van never looks like that.
But I'm also driving a midget like mini transit. So,
and I'm driving a soccer mom vehicle.
Well, I don't even think you have tools anymore.
I do. Shut up. So tonight we're going to talk about.
All right, guys. Yeah. All right, so let's talk about proper vacuums. So me and Brett could argue for 45 minutes. What did my internet go to crap now?
Yep. That's why I turned off the video because you were starting to pause. We were starting to walk all over each other because your internet sucks.
No, my internet is better. It's fine.
Elon Musk can get internet to freaking, Ukraine, but he can't get Kevin better internet. Go ahead and start.
My neighbors have it, and I'm still on a waiting list. So we're going to talk about proper vacuums. So, I mean, there's a lot of controversy about like this and how to pull vacuums and how it's been done and how guys do it. So first and foremost, I want to talk about how I do it. So I pull vacuums with a dedicated vacuum rig, meaning like I have a set of hoses that all they do is vacuums, no recovery, just vacuums. I have a vacuum pump that I keep the oil clean in. I have I do not use gauges to pull vacuums through for anything. I use core pullers and I use when you go out doing this, increase the speed that you're pulling tremendously. Meaning like you could pull a lot faster with a vacuum rig and hoses and larger hoses than you can by pulling through gauges and core depressors. Pulling through gauges and core depressors has got to be one of the biggest waste of times out there. I mean, you're taking a vacuum pump, say if it's rated for a 10 CFM vacuum pump, you're taking that vacuum pump and pulling 0.2 to 0.4 CFM, per hose out of that system. So you're not even pulling an entire CFM. Say if you have a 10 CFM pump or a 6 CFM pump, You're not even pulling an entire CFM if you're using a set of gauges and 1/4-inch hoses. Now, that same system, if you were to take that and pull the cores, you double, almost triple the flow through that same Schrader port. So you almost triple that flow through that Schrader port just by pulling the Schraders and having hoses with no depressors and larger bore hoses. So me personally, I use the Blue Vac stuff. The Blue Vac has been the best that I found so far, just for the simple fact that they are the only true vacuum hoses that will not leak under a super deep vacuum. They're not like black hoses or just colored hoses. Like, these are designed primarily for vacuums only. They will not hold pressure. They're not made for recovery. They're only made for vacuums. So these are basically what would be 3/4-inch hoses that you could change the ends on. And they have KF fittings, which KF fittings are used in industrial vacuums and a lot of industrial applications. They're used for process stuff. Like, they're a special type of fitting with an O-ring in there. So these are designed for industrial vacuums. I mean, these things are tough. So like the benefit is here, I could change the ends on these hoses. Say if I need 1/2-inch ends on these hoses, I'm pulling on a brand new rack, that I'm putting 1/2-inch packed angles on, I could use 1/2-inch hose ends. If I'm doing service and I have Schrader cores, I could put 1/4-inch hoses. Go ahead, Brett.
So I have to ask you, how much is this setup? Because I don't see a green guy going out and getting the Blue Vac setup. What's the setup cost?
Mine was an astronomical amount because I bought it in the beginning and I had to get custom hoses. So now they have, when me and you were down in Florida, I talked to Jim Bergman down there, and they set up a kit where they have 6-foot and 8-foot hoses in a kit. Mm-hmm. I want to say the kit was around like $250, I think, for a core puller, a hose, and 2 or 3 different types of ends. Mm-hmm. So an angled end, a straight end, a 1/2-inch end, a 3/8 end. So like that's not honestly that bad. I mean, a core puller alone is almost $90.
I thought they were cheaper.
No, an Appian core puller is like almost $85-$90. So I mean, you figure you're getting a core puller and you're also getting a vacuum hose setup. So I mean, it's a win-win there. So I mean, that's what I like. I like the Appian core pullers way more. I mean, I think they last better, and like the magnet on the new ones is like awesome.
So the reason for that, because I used to use exclusively Yellow Jacket. That's all I ever used. And like, I don't know, 5 months in, 6 months in, I'd start not being able to pull a Schrader as easy as what it once did. It wasn't because it wasn't latching on or anything like that, but the shaft is actually brass. So what actually ends up happening, like usually when you're pulling out a discharge, if it slips out of your hands, it'll hit back real hard. And because they're brass, the actual shaft there, it actually bends. You can't really see it unless you lay it on a complete straight edge. But that's why, Appian uses the stainless steel for their connection, so that doesn't happen. So that, the only thing that you ever have to change out on the Appian, core pullers is basically the rubber gaskets or the rubber O-rings, and that's usually from, people over tightening them.
So there are only 2 core pullers that are technically vacuum rated. It's Appian and AccuTools. Those are the only 2 core pullers. Yellow Jacket, Hillmore, JB, all those ones are not vacuum rated. So if you're pulling like super low vacuums, like they will leak.
Gotcha.
Those are made for core replacement. Same with the C&D ones. Appian is technically the only vacuum rated one, and I replace them every year.
Yeah,
I lose them way before that though. Like I probably have like 7 Appian core pullers on my cart that are all missing like the stems.
I gotcha. And if you guys don't want to, spend the money for the good hoses, there are some things that you can do to get around that. I showed one of the guys, Greg. He basically took an 1.5 inch piece of copper, welded up both sides, put it on a piece of thin unistrut just so it wouldn't roll around in his van, and basically welded on several service valve fittings. So in this way, he has, on his vacuum pump, he has a 3/8 line, a 1/2 inch line. He can hook that directly to this header, and then basically all the 3/8 and 1/4 inch service valves that he actually has on there. Now he can utilize that to pull wherever a vacuum that he needs to on that rack.
So, okay, there's easier ways to do it than that. You could buy an air compressor block, distribution block off Amazon.
Okay.
Like $20. Gives you a bunch of it's 5/8 bore by 1/2 inch and 3/8 pipe thread.
Mm-hmm.
You can thread packed angle valve straight into it. So now you have
how big's the header?
It depends. You could order them like spaced out. Like you could basically order whatever you want. Like they have it. Like there's so many different types of air compressor blocks. You could do that. Now, like I have that super fancy vacuum pump that the shop has, and then we have that header that we had made with the 7 KF fittings on there. So like I have this giant header that we pull brand new racks with because pulling with copper is pointless, especially on new jobs.
Didn't I just see someone post a picture of that? It was a stainless steel header that had all the I forget what you just called the fittings, the K and N,
fittings. KF fittings. It may have been Nathan. They had one made after they saw ours. But so like we have this giant header made. So like I could take these 8-foot hoses and I can go from basically anywhere. I have 16 feet on each side, so I can get to any side of the rack. So like we're pulling a brand new store. Copper is useless. Okay, you're pulling. So say you have 3/8 copper going to this. Well, that blue vac hose is the equivalent of 7/8 copper. So that it's all in the hose. The way the hose is designed is the way the friction goes through there. So you are picking up all this friction with this flow on a 3/8 copper line that's reducing the vacuum speed. Now,
and that's sorry.
Go ahead.
I was going to say that's why, like pulling through a service valve that has a Schrader in there versus, like it just if it has the threads or if it's just smooth. Believe it or not, that actually makes a difference. Because it actually has the ridges in there that the Schrader actually pulls into. It resists when you're pulling a vacuum on it. So that's why they tell you, for the most part, you try to hook up to any fitting that doesn't have any resistance. Basically, no Schrader, no threads in the inside. It's just that will pull a vacuum a hell of a lot faster than anything else.
Yeah, I mean, so like I'm actually using a micron gauge every time. So like, but even when I'm doing service, like I'm pumping stuff down. I'm using core pullers to pump everything down. After I'm done, I have the core puller still hooked up to the circuit or to the case or whatever I'm doing. I'm using those core pullers to pull vacuum now. I have I'll slap a micron gauge on there instead of my stubby gauge. I'll slap a micron gauge on there and I will use that to pull. Yes, in an operating supermarket, you're not going to hold microns. You're not going to do a decay test. You're not going to hit microns every time. Let's be honest. Ball valves bleed through on a 20-year-old system. Yeah, I'm not expecting to hit microns. Okay. I'm not expecting to hit 500, but I want to see it get under like 15,000. I want to make sure there's not like a gaping leak somewhere or like something like that. But it's just getting in the habit of doing it all the time, using that micron gauge. I mean, the more you get in the habit for it, the easier it will be to pull vacuums on new jobs. I mean, for God's sakes, the last 2 racks we did, in less than 4 hours, we had an entire CO2 rack below 1,000 microns.
Is that when you were pulling off the reliefs?
Yes. So like with that, like if I'm doing a brand new rack and I don't have, say the manufacturer screwed me and I get the value rack special, they give me give you 1 3/8 packed angle valve on the liquid line because that's all we need. So say I get that and we don't have any fittings and I get the old manufacturer, corkscrew, I will pull the reliefs off. Okay. And I will thread in fittings into the reliefs, usually like 1/2 inch fittings. And then I will hook the blue vac hoses up to them. So like, that's why like I have a vacuum kit, recovery kit. Like it has all kinds of stuff in there. 3/8 by MPT by flare, 1/2 inch MPT by flare, flare reducers, all kinds of stuff. Anything you could think you're going to need brass wise, I have. I have a ton of 1/4-inch female flare to 3/8 male flare reducers. So that way I could take right from my core puller. So say I'm doing a big recovery, I'll take from my core puller, I'll thread on the after I pull the core, I'll thread on a 3/8 adapter. Now I'm pulling a 3/8 into my recovery machine, or a 3/8 into a vacuum pump if I need to. So I'm blowing it up at the outlet of that. The bigger the hose, the better you go, the less friction you have. It's not so much dependent on the inlet of the hose. It's more dependent on the actual length of the hose and the amount of friction in the hose.
Can we refer to getting screwed as now getting Kevined? Like when it comes to like the manufacturer mess up, can we refer to it as getting Kevined?
Oh yeah, I got a good one that I got to talk to you about later. It's going to make you
now.
No, because we're talking about vacuums. It's going to make you really scratch your head.
Okay.
And I was told that I'm not an engineer, so
You're not.
I know. I just fixed what they don't do right. Okay, so this is what I do all day long. Is just fix things that engineers like think will work on paper, but don't.
Maybe there's a reason why we've had like 2 engineers on this podcast.
Yeah, but the engineer we had on was like Joe was like super smart. Like he actually does his job.
Your hate for everybody is astounding.
I don't hate everybody, just most engineers. Okay. All right, back to vacuums. So again, now I want to get into this whole myth of freezing water, because here we go. You're not going to freeze water in an active system. No, you're not.
Yes, you will.
No, you're not. Do I have to get other? Listen. Right. On an active live system, okay, we're not talking a jar of water that is sitting on a table as a parlor trick. That's all that is a parlor trick. Okay, all you're doing is freezing water on a table by pulling a vacuum. That's cool. That's great. But guess what? There's not that much water in a running system.
Okay, all right.
You have
in a
more
running system. In a running system, yes, but a system that just got doused with water because of a chiller breakage or a glycol breakage.
100% different situation. Like, okay, we're not talking.
The water is still going to freeze. Ask NASA. They pee outside, it freezes.
Listen, take it from somebody who had a rack completely flood all the way up to the condenser. Yes, we'll go over that. But you are not going to freeze water by pulling a vacuum too quick on a system that was running before.
And why do we warm up coils when we're trying to pull a devacuum on something? Like,
I mean, it's gonna boil any refrigerant on the oil by warming up the coils, but you're not going to freeze water in there. Okay, A, how'd the water get in there? And B, what's going to happen to the water once it freezes?
My copper plating rack that took out every single compressor says different. That
your copper plating rack is because people don't know how to pull vacuums.
No. It was a comm issue that caused the rack to go in a bump down.
Yeah, but that wasn't that was from the rack pulling a vacuum itself.
Yes, so it was pulling moisture non-condensables.
Yeah, well, that's not from pulling a vacuum. That's from the rack pulling its own vacuum.
Pull moisture into the system.
Okay, yeah, pulled moisture in the system, but like that's not what we're talking about. We're talking about actually pulling a vacuum too quick. That is not going to be an issue you have in the field. You're not going to freeze moisture in there. And if you do, guess what? It's going to simulate, or I don't know if I said that word right. It's going to dissolve. It's going to warm up and it's going to pull out. How do you get moisture out of a system? You let it sit on a vacuum pump in a deep vacuum. Not doing triple evacuation, which is a complete waste of time.
I'm getting a NASA engineer and we're going to discuss this.
That's fine. This is not NASA engineering. This is like hillbilly refrigeration.
Mr. Indiana.
I'm just saying you're not going to freeze water in a system. Okay, and guess what? If you're worried about it, warm the system up. Keep the crankcase heaters on. Force the heaters on in the freezer.
All right. I do agree to disagree.
No, this is good dialogue. Like, you're not explain to me how you're going to freeze water by pulling it too fast in a system if there's no water in there.
I'm saying if there is moisture in there.
How you would have to have a substantial amount of moisture, but even if you did, okay, say it's a brand new system.
These residential cats that have piston tubes block up because of a little bit of moisture. Not like someone's dumping a freaking Poland Spring bottle down the suction line. Well, let's see what happens here. No, those things can't. What?
That's not happening. Those guys care way too much about airflow. I mean, you're talking a piston that he's going to block up. I mean, come on. Take it from somebody who pulls vacuums for a living. Like, that's all it's half my life on these construction startups is pulling vacuums. You're not going to freeze moisture. And guess what? If you do, you're going to see it on a micron gauge.
Agree to disagree.
No, there's no agree to disagree. Like, it's a blown out of proportion thing.
You know, we knew this was gonna happen.
Oh yeah, and I love it because I'll take a good argument right now. Like, this is good. I mean, you're not going to freeze. Okay, so what's your thing? Pull the vacuum slower?
So why? No. But that was the whole purpose of doing the triple evac, where you blow nitrogen.
That wasn't the purpose of blowing a triple evac. The purpose of a triple evac was from back before they had 2-stage vacuum pumps and reliable micron gauges, 100%. Because purging nitrogen through a system does not pull out moisture. 100% does not.
I'm booking Appian. Appian, if you're listening to this podcast, you can break this discussion.
I mean, nitrogen has no ability to absorb moisture.
Okay.
It's going to
not saying you can't push it through.
You may push it through, but guess what? Where do you do the most dehydration? In a deep vacuum.
Usually Usually when I'm making beef jerky, I use the dehydrator.
Okay, yeah, but like, I mean, as you're dehydrating, you're pulling a deep vacuum. So like, if you want to dehydrate the system, pulling a deep vacuum is that. Triple evacuation is a complete waste of time.
Well, you can't do it on a rack anyway that's in service.
Well, yeah.
Don't ever. So by the way, while we're talking about it, never, ever use nitrogen on a live system unless whatever you're pressure testing is completely cut off and capped from the system. There's a guy that gotten some doo-doo because he basically pressurized, he couldn't find a leak, pressurized it, and ended up putting nitrogen into a system that had active refrigerant in it. It didn't like that, and the ball valve wasn't holding, and I guess that was why he wasn't pulling a vacuum. So don't do that.
He had no issues in the wintertime, though, with head pressure, though. Ain't great.
Awesome subcooling. There was like 80 degrees of subcooling coming off the liquid line.
Yeah, so I mean, what triple evacuation and it is a complete waste of time. It is. If you're going to triple evacuate with refrigerant, hell yeah, that works. I mean, it's completely illegal, but like, refrigerant absorbs moisture. Jesus, that works. I mean, if you're going to do it with nitrogen, that's a complete waste of time. Now, I will say this: there's a company in Chicago that is using heated nitrogen, like when chillers break tubes. They're taking heated nitrogen, high pressure heated nitrogen, and blowing it through a chiller.
Mm-hmm.
That would be effective because now you're heating and raising the boiling point and boiling out any moisture.
Of the moisture, so it doesn't freeze. You're right. You're absolutely right. Exactly what you just said.
But it's. I hope you fall over in that chair. You're not going to. It's not going to be an issue in a live system.
I've seen water freeze in a jar.
Yeah, you've seen water freeze in a jar like a parlor trick. It literally is a parlor trick that I wish they would stop teaching in trade schools because It literally just makes this whole like thing of, oh, you're gonna freeze the moisture in there, and you're pulling a vacuum too quick. No, pull a vacuum as quick as you can, get as deep as you can, as fast as you can, so that way you could sit down there in a deep vacuum and let it pull. Because guess what? If you ever watched a micron gauge, if you ever watch like Jim Bergman do like a presentation on this, like on the blue vac gauge of like what it looks like when there's moisture on there, like the spikes and the gauge, like you could tell right away when there's moisture.
I'm calling Appian. Hello, guys. With the addition of having Field Pieces, one of our newest sponsors, we're going to be doing a tool giveaway from the months of April to December. The way this is going to work is we're going to give questions out for the first 3 podcasts of the month. Once you get the answers to these questions, you're going to send your answers to advancedrefrigerationpodcast@gmail.com. And in the subject title card, you're going to put tool giveaway. At that point, the people that answered the questions correctly will be put in a drawing to see who would win that tool for that month. Thanks, guys, and good luck. The first question is, what is the legal limit in weight that you're allowed to charge a self-contained up to that contains propane as a refrigerant? Today's episode is sponsored by the new Reefer Shield differential pressure monitor from Westermeyer Industries. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Way too long to replace and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The new Reefer Shield RDP-01 differential pressure monitor is available now from Westermeyer Industries. To find out more information, email sales@westermeyerind.com. That's sales@westermeyerind.com. I have their card somewhere.
Whatever. If you want to talk about vacuums, you got to get Jim Bergman on. That man knows more about vacuums than anybody out there.
Okay. Jim, if you're listening, if you want to be on.
But what I'm saying is, like, don't be worried about pulling like stuff like that. And if you guys can't afford a vacuum kit, right away, you can make your own. Okay. So like you can get some 3/8 hoses and use that as long as they have good hoses in there or gaskets in there. Appian, for example, they make a super cheap kit where they have an Appian core puller and a 1/4 inch by 3/8 hose. Works great. I had one for years. I ended up giving it away when I got the blue vac stuff, but like that Appian hose works great. It's like 6 feet long. It's still way faster than pulling through 1/4 inch hoses. It ends up working great. I mean, you could end up pulling vacuums a lot quicker. Having a good vacuum gauge. Blue vac. Field piece makes a good one. Just anything but that thermodynamics one where it's like the needle gauge.
So I've had the same vacuum gauge for a very, 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 very long time. I have the yellow jacket one that comes in a little case there. And man, that thing's lasted, I don't even know, 15 years.
The blue vac one is like a love-hate relationship. Like,
yeah, what was that?
You'll love it and you'll absolutely hate it because there's no cheating it. And you'll learn how many leaks you have on your vacuum rig with that thing very quickly.
Really?
Yes, it is the most sensitive vacuum gauge that I've found.
Probably sensing all that ice in there.
Yeah, all the ice in there that's not there from pulling a vacuum too quick. You should see the 34 CFM vacuum pump just clapping away with the 8 hoses on there.
Yeah.
Making all that ice. Now let's talk about if there is that much moisture. Okay, Brett, since you're the resident pro ice man, how do you get rid of the flooded rack?
I use a whole bunch of heat, just something to heat the equipment. So if it's a chiller, right, you're gonna drain out all the oil or all the water that you can, and just try to flush every little bit of it, moisture that you got in that system out. And then at that point, it's nitrogen and vacuum and nitrogen and vacuum and nitrogen and vacuum back and forth, just trying to push out all that shit that's in there. And sometimes that doesn't even all work. There's not, those chillers aren't made to have that bank of, water in there. So there's no drain on that section of the chiller, because otherwise you'd be draining off the suction, right? So
What about a rack?
On a rack? Oh, I don't even know how that's. How'd you what collapsed that you got water in the rack?
So this was a manufacturing plant that I took care of. All T&M, like they had their own maintenance there. They would only call when they've broken it like 15 times. So this particular day that I ended up going there on a weekend, they couldn't get the rack back running. Thing holds like 2,000 pounds of gas. Told me they put 50 pounds of gas in there, and it took off. So we started like going through it, realized that the suction filters had frozen.
Sweet.
Like completely shut. And then the thing wasn't actually full of refrigerant, it was full of water. So what we ended up doing was shutting it down, blew off the gas, whatever was left in there, which was nothing basically. We found all the low points, drilled holes in the traps, let them drain, pressurized it as much as we could to, blow everything out everywhere, lock the heaters on in the freezers to warm up the heaters and boil out the moisture inside of it. And then we basically just let it sit on vacuum pumps for as long as we could with heating up the receiver. We tarped the condenser, put turbo heaters on the condenser because it was the middle of winter or fall. We put turbo heaters under the condenser, heated it up, basically heated up as much of the system as we could, and then just kept vacuum pumps rolling on it as long as we could. And then when we went to go start it up, I've never seen this done before, like besides this place, but one of my bosses was out there and he filled the dryer shell full of tampons.
That's amazing.
Apparently I looked it up. Like it's like an old school thing because they're absorbent. So, and then, there was a bunch of this moisture away crap that we put in there from New Calgon, like
or acids. Is the acid scavenger?
Yeah, acid scavenger. We put like a gallon of it in.
Yeah, well, I mean, it tells you how much to put in per, however much refrigerant it holds or whatever. Because so on that chiller that I told you that ruptured, because it was a processed chiller, they were like, it needs to be running now, and like it's not done. Like I was still getting milk out of the vacuum pump. And guys, what I mean by that is, after pulling a highly saturated system that has a boatload of moisture in it, that vacuum pump oil will basically turn into a milky white substance. I've had it happen on a Kramer thermal bank. I had it happen on a chiller, and basically, I was getting harped. They were like, this is costing a lot of money to have this down. I'm like, but it's not fixed. And they're like, well, we want it up. So I started up, and on these, on the train rotary screw chillers, they have a screen, and the unit pump, like it pumped down. I added the correct amount of charge, and it pumped right down. And basically it was doing the same thing that you just said. It was creating a Venturi effect, and all the moisture that was stuck in there was, stucking up the little strainer that's in the back of the suction. Go in there, scoop pump it down, scoop this, take apart the service valve, scoop out the snow that's in there, throw the snow out, put it back in, do that a couple times until it stopped pumping itself down.
Yeah, the first time we started the rack up, my boss jumped the gun and we didn't let it pull long enough because his place was the same thing. Like we need it now. And I just remember the apprentice like laughing. I'm like, what are you laughing? We started up. He's, what are you laughing about? He goes, there's ice floating in the sight glass right now. Then all of a sudden, like 5 minutes later, you see the rack pump down. I'm like, what? Look over there. There's like an ice chunk is floating around the sight glass. There was a liquid outlet pressure regulator on the liquid line. It actually froze the valve shut. So that was, and then by the time we dumped the gas again and started pulling a vacuum, that gas we dumped had absorbed a lot of the moisture, and we pulled again. But I mean, at that point, using nitrogen, if he was heated nitrogen, it would probably work pretty good. But like normal nitrogen, you're pretty much not going to do anything. You just need decent vacuum pumps and a cold trap. So a cold trap is something like the chiller guys use a lot. So a cold trap is actually like a vessel inside of a vessel. And what you do is, so you have this outer vessel that the vacuum pulls through. Okay, it sucks in one way. Think of it like an oil separator. So like a Temporite or a Westermeyer oil separator. You got the big lid on top. So inside of that, there will be another vessel that is sealed up that you fill full of dry ice or liquid CO2 or refrigerant or whatever you do. And that inner vessel is going to be super cold, as cold as it could be, freezing below dew point. And what happens is the point of a cold trap is that vapor coming back through the system is going to come into the cold trap, and it's going to freeze to that actual cold trap, to where the dry ice is, or liquid nitrogen or liquid CO2. It's going to freeze to that. And what this is going to do is allow the non-moist air to go to the vacuum pumps, because what ends up screwing you in this situation is if you turn that vacuum pump oil milky, now you're not absorbing any moisture anymore. You're not getting it out because the vacuum pump oil is trash and the vacuum pump's not doing any work.
It's oversaturated. You can't. It will. Like if you ran a test with milky white oil, you might be able to run down to maybe 500 microns. If you can get it, if it's where it's brand new clear, you might be able to get that micron gauge down to like 6 microns.
Yeah, I mean, the whole thing depends on the oil. So what the cold trap does is protects your oil. It makes you, so instead of like, okay, in that situation, we had a cold trap, instead of getting, 20 minutes out of a vacuum pump like we were before, the big like Welch vacuum pump, we were getting 2 hours out of a vacuum pump.
Question. What are your thoughts on using the gas ballast? There's not very many people that even know what that's used for.
So I run the gas ballast when I'm below like 900 microns
first.
So the gas ballast basically is it diverts the gas inside the vacuum pump, so it doesn't come in contact with the oil as much. It diverts it through the first stage. So like if it's a 2-stage pump, it reverts it through the first stage and out. The reason you want to use this is when you're first pulling, you want to keep as much of that vapor out of that vacuum pump as you can. It does two things. It takes the load off the vacuum pump, and it allows you to vent off any vapor or refrigerant and keep it out of the vacuum pump oil. Using that will keep your vacuum pump oil fresher longer.
Yeah, I just want to bring that up because I had mentioned that I was shooting videos last week. I was in California. We were shooting videos, making some videos, and basically the kid asked me, he's like, "What's the gas ballast for?" He's like, "I've been doing this about 3 years, and I don't think I've ever used it. I don't know what it's for."
Yeah, so. that's where like the app or the Appian and the field piece ones in Navac real nice. Like field piece is like super nice because the gas ballast right in the back. It tells you if it's on or not, and you could actually hook a hose right up to where the gas ballast port is and just throw it out. So if you're like pulling a vacuum on something where like the valves are bleeding through and you're trying not to choke to death while you're burning something, you could hook a garden hose up to that and vent it outside.
Gotcha.
But that is the point of the gas ballast. But like the whole thing here, guys, is like ditch pulling vacuums through gauges. I mean, pulling vacuums through gauges is like a dying thing. I know it's like convenient for most guys, but in the end, it's really not convenient when it takes longer. So would you rather it take longer in the middle of the night, or would you rather it be done quicker so you can get out of there and get home? I mean, that's the whole thing. I'd rather my vacuums be done quicker so I could spend time on other things. Pulling vacuums through a dedicated hose rig, once you like actually do it and you actually see it, it's so much faster. And then not using a set of gauges and pulling down to 27 inches or 28 inches, using an actual vacuum gauge or like a digital gauge. I mean, in doing it properly, I mean, you're going to stop these like getting air in racks. You're going to stop this. And just actually pulling a vacuum, because let's be honest, there's some old timers out there that don't pull vacuums and still purge. I still see it.
I don't know what you're talking about. So anyway,
Brett.
bullshit. No, absolutely not. He's not talking about me.
That still happens. And this
I-
Windows 11 laptop just booted up finally. What is this? An hour later?
That's amazing. So one of the things about, getting a little, I can't freaking talk today. A little bit more longevity out of the micron gauge, put a ball valve on there. This way, when you reintroduce the refrigerant to the system, you don't damage it. We don't want any. That they also tell you not to start the micron gauge until you at least hit 30 inches of water column before you actually start that thing.
See, that's where the blue back's nice. It'll take 300 pounds.
Well, I'm sure that's not the intent of it, right?
Oh no! Like they literally say, like you could start it up with, you could leave it on there with the system running, and it is completely fine.
I find that hard to believe. That's it. Another question for Bergen or Appian.
Does Appian even make a vacuum gauge?
No, but they know. I don't know. Probably they make regular. Well, they make regular gauges, right?
Those stubbies are awesome.
So,
I mean, so guys, yeah, that's the whole point here. Actually, pull a vacuum. That's the whole goal of this, and like actually like introducing like we'll send some videos out like eventually of like how I pull vacuums and how I'm accomplishing it and exactly pulling it. I mean, there's some more news coming up soon with us that maybe we'll do some vacuum videos. But all right, guys, have a nice one.
all right, later, guys.
Well, they say all good things come to an end.
What's that got to do with this show?